Okay, so today we're going to continue what we have learned and discussed before. Initially, last time we talked about the historical part of the wind power technology, and then we continue with design consideration on how to make one power, how this wind power operation works, and also about its control mechanism. So we have gone through all these details, and today we're going to talk about a little bit on the process of installation to commissioning. Okay, how could that be? Okay, let's move on. Okay, the first part is about the installation of the wind turbine. So whenever you would like to install the wind turbine, number one, we need to understand where are going to install it. Okay, if it is onshore, okay, onshore has its own requirement. If it is offshore, there will be another set of requirement. The basic rules are the same. All the design, all the poles, all the system, mechanism, everything is the same with respect to the current environmental condition at that place, but the only difference is how you are going to install it. Okay, if it is onshore, you need to make sure that what will be the size of footprint that you need to have, how big is the size of the foundation you need to make, and so forth. But talking on offshore, there are a little bit more other parts. There are several techniques that you may be able to work on. Okay, because it is on the sea, so one way is to, if it is very deep offshore, so you cannot have some cable attached to it. You need to make it float. So you need to work on the floating design as well. So, sorry, apa keluar ni pula? Okay, so basically, depending on how much energy that you require, how it is going to be distributed, whether you want it to be standalone or you want it to be basically to sell to the grid, the size of the turbine, okay, and the next will be the optimization or optimal design of your wind turbine. This is a little bit, the most toughest part is this one. So basically that you really need to have this, the optimal design for that area, okay? Whether you need to work on the 3 blades, how much will be the wind speed at that place, the height, and also what about the loading of that you are dealing with. Okay, foundation type is if offshore, monopile, and so this is a little bit more detailed in nature for us to discuss. Okay, those who are going to be working in oil and gas industry soon, especially on this field, you may be able to be introduced on this again soon, training by UTP, for example. Okay, steps. Okay, this is very common to everyone. This is all the basic. Clearing site, construction, road, if it is onshore, and then determination of, foundation process. Okay, and then you need to put everything out together. If it is onshore, that will be easier for you to carry on all these things. But if it is offshore, then you need to worry on bringing them over on the big ship and everything, and install piece by piece offshore, which is very, very expensive. So in order to do that, you really need to make sure that you need to get all these things maintained properly. Otherwise, that the system can be easily damaged, as you can see here. The size of this engine will be, as you can see here, like people can stand over within that area, this engine. So if it is burned off, it is not easy to maintain because it is all the way up of 80 meters high. So if something happens to this engine, then you just simply say, okay, just finish off everything, we take them down and make one, that's all. Make a new one. So the point is, you really need to make it safe. You should be able to ensure that it can be monitored correctly, okay, in order to prevent this from happening. Okay, otherwise that one things happen like this, you cannot do anything much about it. These are very expensive things, and you cannot afford to, to have all these issues when the system is in operation. Okay, and in fact, there are lots of videos available online that you can see the real, damage occurring to your system. So, gearbox problem similar to the one that you have a car. Whenever you have a gear, the gear can be losing up. You need to be greased out sometimes. Okay, so basically, in terms of gearbox problem, we need to make sure that everything should be in the good shape before all this thing high temperature operation can occur. So basically, that you really need to understand how all this work in this, especially environment, to protect the gearbox of your engine. Now let's look at this condition monitoring. So in terms of this condition monitoring, nowadays, especially in Petronas, we are compulsory to understand how AI works. Okay, so what is the difference between, what do you know about AI? Let's say that you want to monitor this. Okay, your boss says, please work on AI. So what do you know about AI? How AI works in order to monitor? Let's say that I'm your boss. I ask, okay, Nick, Afiza, please suggest what do you know about AI to monitor?
AI will make the decision whether we need to maintain or not based on the data.
Okay. Half correct. It's true, but it is not complete.
Using AI to predict problems based on real-time data.
Same thing. So basically, what is the difference between whatever you say and the current method that they are using? They still are using some data as well. So from this data, we have the predictive method. Have you heard about predictive method? It's to predict what happened, and then the system will predict based on data, okay? And it will tell the engineers to execute, right? Some other change or whatever setting. That is what we are doing now. It is not AI. AI is something that in addition to that of the prediction, the system will decide whether to correct or not correct. Because in the predictive method, the system will predict and suggest to Afiza that this parameter needs to be changed. You have to change. AI no. The system will decide whether it is time for you to change or not. That's AI. It is decided not by human, it's decided by the machine. Machine will decide sama ada to execute or not. Maknanya whatever that you say is okay, but on top of the decision, on the execution part, it is not by human. It's done by machine. That's why lots of the new current robotic technology in the world now, they have the walking robot and everything. It is not by remote control or anything. It's just like decided by the machine. So that is the AI robot. Okay, so this is very common. So actually all of this will be like monitored. Okay, and this monitor, so predictive monitoring means something happens, then only the system, the engineer will come and try to change or fix or whatever it is. Okay, AI is a little bit different. Okay, what condition that the system can monitor all these things. So all of these will be basically having a mechanical part and software. To be specific, AI software. Okay, in order to check and everything. If there is, if there is any issue in the shaft deflection, the AI will basically do that part. The AI will basically change the angle, or not to change the angle, or to change the angle, not now, but maybe in the afternoon, it will decide. All of this AI action or any decision that AI can do, basically the users will know. But when, we never know. The system will control and decide, okay, by themselves. Okay, so that's why we really need to train them. Okay, so in terms of this wind cost projection, okay, there are rules, all right. For offshore also same. We have the fixed bottom, we have a floating offshore. So we need to know that if it is like shallow water, we can just use maybe fixed one. We take all the cable and everything. So if the deep sea, we need to work on the offshore. So all of this we need to, the cost incurred has to be calculated carefully so that we are not going to lose. Okay, all right, on this one. So most of the oil offshore production based on this wind turbine will last around 20 to 25 years. So within these years, you need to really calculate economically that you need to come out with the returns of your investment, say earlier than that, maybe in 15 years or so. Otherwise, it is not applicable to work on this project. There are smart initiatives, okay, by mostly on the European North Sea region, that they say that all of this future future wind turbine production can reduce up to 50%, meaning that they have new technologies, they can optimize the material use and make use of the level of the wind speed to optimize the operation of your engine and everything, and consequently they can get more per kilowatt hour peak results or production of electricity based on this one. So at the end of the day, we want to have a system like, say, for Petronas, for example, you can design something much more cheaper and can last 25 years and earlier return of investment, and most importantly can present a good tariff to the consumer. So that is why at the moment the Petronas are not like IPP, is not having a license to provide any energy, but they can provide the energy to themselves. Okay, but still within the scope of the Suruhanjaya Energy Commission as well. So they cannot just simply, even though they have some money, they want to do it at any time they want, not really. Okay. Okay, the last part on this topic is in terms of some of the applications. So there are lots of applications in terms of wind turbine. One is what Petronas is doing in Baram, and now they are trying to embark a little wind turbine technology installed on the oil platform. Okay, oil platform. So we need to know whether it is feasible or not. So all of these examples here are already been done to show that there are cases where people have been working on this wind turbine for quite some time already. For example, on this example, using wind turbine for water pumping. Okay, so some of the example and so forth. For these are for the agriculture. Okay, what you are seeing here is the major production, not the simple one. So they are using this to suck in water for agriculture. This one is on the Mongolia. This is for electricity. They are having this combined PV and wind hybrid system pilot project for this area to sustain of the certain 120,000 household of getting this energy at that area. So this is all the information that they are using, wind and PV, and some of the tariff that have been charged to consumer for this one. Okay, for all the standalone for home. For business, example in Philippines, There are a small project, and this is installed in one of the islands in Philippines for the consumer. I mean, the people are living there, of course. So they are using this one. But the key point is you really need to have the enough wind speed as we discussed before in order to manage that. And last one is in the Antarctica area. And as far as you go away from your equator, the more wind speed that you can have. So basically that definitely there will be lots more wind speed down there, whether in the Arctic or in the Antarctic. So there should be no issues of applying wind turbine there. Okay, and the last is on the grid connected things is in 1998 a project done on the Costa Rica also. Okay. All right, some review topic on lesson learned. Okay, so you can just see on number one is how much area of the wind are you pumping on Ain Toba. All of things are actually coming from the case study or the sample question that you have. So you can just look at that, okay, at home and look on that case study and try to see what will be the answers are there, and there will be a little of the feedback link that you may go through and try to key in, any feedback that you may want to add based on up to this lesson 3 that you have learned. Okay, so I guess we just take a break, and later on that we can come back. So I guess any question before we end this part 3? Any question? Okay, so in that case, you can take a break now. Thank you very much.